Hello everyone, welcome. In this video, I will be covering section 2.1, which is the topic on limits, which is the most important topic for the development of calculus. This is the beginning of calculus. And in this section, we are going to be also covering tangent and velocity problems. So these concepts will get repeated all of chapter 2. So what is the tangent and velocity problem here? The word tangent means the one that touches, Thus, a tangent to a curve is a line that touches the curve. So here you see a curve, which is a circle. And here you see the tangent line that touches the curve at a single point, at one point. The slope of a line join of 2 points, x1, y1, and x2, y2 from our algebra class is the difference in y coordinates over the corresponding difference in x coordinates. The slope of the secant line joining 1, 1 and xy on the parabola y equal to x square is, so if you take the parabola y equal to x square, and you take a point x and y equal to x square, then x coordinate 1 means y coordinate, it's a square. X coordinate 2, y coordinate is its square. X coordinate x, the y coordinate is its square. So we are taking these 2 points, 1, 1 and x comma x square, and we are finding the slope of it. So that means that we have to do the difference in y over the corresponding difference in x, correct? So it is x square minus 1 over x minus 1. So this is for any 2 points, any point with coordinates xy, which is a neighboring point of the point 1, 1 on the graph. The slope of the tangent line is the limit of the slopes of the secant lines. So what we mean by this limit is that whenever we find the slope of a line, we need 2 points. But the tangent line being tangent, it touches the curve only at 1 point. So we have only 1 point on the tangent line. So what we do is, because after all tangent is touching the curve, we are taking many points to the right side of the point at which tangent is drawn. And then each time we find out the slope of the secant line. Similarly, we take many points on the left side of the point where the tangent is drawn, tangent is needed, and then we find out the slope of the secant lines. So then, wherever the slopes of the secant lines approach to, which is the limit of, then it becomes a slope of the tangent line. This is the idea. Find the equation of the tangent line to the parabola y equal to x square at the point 1, 1. So we need the equation of the tangent line to this parabola at the point 1, 1. So if you look at this graph, what we want is the equation of this tangent line. This is the equation of the tangent line at the point P, 1, 1. So in order to find out the equation of the tangent line, what do we need? We need the slope. We already know the point 1, 1. So once we find out the slope of the tangent line, we can write down the equation of the tangent line. But we don't have another point on the tangent line. So what we are going to do is, we are going to pick points like Q on the right side of P, and then we are going to allow Q to approach P. Then each time, we are going to find out the slope of that line. And then they take a point closer, take a point closer, take a point closer on the right side of P. Then each time we find out the slope of the secant line. We do that for the right side, and we have a set of values for the right side slope. Similarly, we take a point Q on the left side of P, which means that the x coordinate will be smaller than 1. On the right side of P, it will be small, greater than 1. So we get a set of slopes. On the left side also, we see where the limits approach to, where the slopes approach to. So wherever these two values approach to, that becomes a slope of the tangent line. So that is what we do here. So if we choose a nearby point q x comma x square on the parabola to find the slope of the secant line PQ, we choose x not equal to 1 so that q is not equal to p. So it's not a coincident point. We take a neighboring point, either to the right or to the left. So P has coordinates on the parabola 1, 1. Q is a neighboring point. We call it x comma x squared. If the input is x, the output is x squared. So what is the slope of this line? This will be difference in y coordinates over the corresponding difference in x coordinates. So it will be x squared minus 1 over x minus 1. Now we will pick a specific value on the right side of P. So let's say Q has coordinate 1.5, then its y coordinate is its square, which is 2.25. Now for these 2 points P and Q, now we are going to find out the slope, which is difference in y over the corresponding difference in x, difference in y over the corresponding difference in x. So which will be 2.25 minus 1 over 1.5 minus 1. We can use our calculator to compute this. So now I'm going to plug in 2.25 minus 1 over 1.5 minus 1 on in the calculator. For that, I go to the home screen where I compute. So I need the fraction form. So I use alpha and alpha followed by y equal alpha followed by y equal to so that on the home screen. So I need alpha y. So that gives me numerator over denominator, the first menu. That one I plug in 2.25 minus 1 divided by below, it is 1.5 minus 1. Of course, this can be done without the calculator, but we will be doing that for many values. So we will use a calculator. So this value turns out to be 2.5. So as I mentioned earlier, now we are going to create a table for the slope for several of the values close to 1. So we'll pick x values to the right side of 1 and some values, x values to the left of 1. So each time we will find out the slope, MPQ. What is P though? P is fixed, which is 1, 1 in the parabola. So for that, so what we are going to do is this computation, M of PQ, which is x squared minus 1 over x minus 1 for different values of x. We already did 1.5 that is shown here. 1.5 is already shown here. The slope turned out to be 2.5. Similar computation we are going to do taking x values, different x values. So I'm going to use this formula in my calculator. So I'm going to plug in, let me go to y equal to, that y equal to, you bring in the numerator in the denominator form, which is alpha followed by y, pick the menu 1. So here you plug in x square minus 1, x square minus 1, in the denominator, x minus 1. All right. Now what we are going to do is we are going to take a table. So this is stored in y1. So you can graph this. But what I'm going to do is I have to use this table that I have drawn here for various values of x. So let's use the table feature, before you do so, you hit second and window, which is table set. So here you're going to make your independent variable ask, which means that you can plug in any value for X. Otherwise, the table will automatically create for you, which you don't want. You want the table created for specific values that you input for X. Then let's leave the independent variable in the auto itself. So whatever value you input, that's going to give you the output. Input is the independent variable, output is the dependent variable. And now you go to the table, which is second followed by graph, this gives the table. So you're going to input the X values that is shown in the table here. So let's plug in the value 2 and hit the enter. That gives me 3. So that is actually the slope. So what is Y1? Y1 is actually the slope. Slope formula is what we wrote. Then 1.5, which we already computed, just to make sure that we did it right, which is 2.5. So then you plug in 1.1, hit the enter, that is 2.1. So I'm writing that in the table as well. Then 1.01, hit enter, that is 2.01. The next one, 0.001. So hit enter, 2.001. Then I see a set of values on the left side of 1. Let me start with the 0. 0, hit enter. That is 1. Then 0.5, hit enter. That is 1.5. Then 0.9, hit enter. That is 1.9. And 0.99, hit enter. 0.99, hit enter. That is 1.99. Then 0.999, 0.999, enter. That is 1.999. 1.999. So what we learned from this table? So as you choose X values to the right side of 1, and when you compute the slopes, these values over here are approaching, 2, approaching 2. Same way, as you choose values of X, and then to the left side of 1, and then when you plug in, when you compute slope of PQ, they also approach the value 2. Approach, the word approach means in calculus, it is turned into limit. So the limit of the slopes on either side, the limit of the slopes of the secant lines on either side of P approach the value 2, which means 2 is the slope of the tangent line. So this is a longer way of doing it, but this is a table method. In the next section, you will be learning how to do this easily without these tables. The limit of the slopes MPQ of the secant line is the slope of the tangent line is 2, and it is the slope of the tangent line. Where does the value of MPQ tend to in the previous table? We know that it is 2. The slope of the tangent line at P11 is now 2. So can we get the equation of the tangent line easily now at 1, 1? Yes. So what we need is the point and we need the slope. We have found out the slope, which is equal to 2. So the equation is y minus y1 equal to m times x minus x1, where x1, y1 are 1, 1. So y minus 1, the slope is 2, x minus 1. So if I simplify this, So if I distribute the 2, I get 2x minus 2. Then move the negative 1 to the other side, it becomes 2x minus 1. That is the equation of the tangent line. Wonderful. Now we'll try a similar problem, except that instead of y equal to x square, we are going to use a different curve, y equal to 1 over 1 minus x, which is rational. Then the point P is 2 comma negative 1. Then we are going to find out the slope of the tangent line at P 2 comma negative 1. This problem is a problem on the practice exam, on the practice test, and also it is a problem on the exercise, which is problem number 3. So which you might find it in the homework too. The point P 2 comma negative 1 lies on the curve y equal to 1 over 1 minus x. If Q is the point x comma 1 over 1 minus x, use your calculator to find the slope of the secant line PQ. Correct to 6 decimal places for the following values of x. 1.5, 1.9, 1.99, 1.999. Then 2.5, 2.1, 2.01, 2.001. B, use the results of part A, guess the value of the slope of the tangent line to the curve at P 2 comma negative 1. Using the slope from part B, find the equation of the tangent line to the curve at P 2 comma negative 1. So you notice that these set of values over here are increasing from 1.5 to approaching the value 2. So it starts at 1.5, steadily increases to the value 2. 2 is the point where you want the tangent at. So these are the values. These values are smaller than 2. The next set of values, 2.5, 2.1, 2.01, 2.001, start from 2.5 and decreases, but these are values larger than 2. So it is larger than 2. Why did we pick 2? 2 is where you are going to, 2 is the x coordinate of the point P where you want the tangent at. Right? As I said earlier, this is also problem number 3 of the practice exam. So as I need more room, I'm going to take this problem down the page and I'm going to create a table, one set for the values smaller than 2, one set for the values larger than 2. And you also notice that here we are going to find out the slope MPQ. What is MPQ? P is a point in this case 2, negative 1. And Q is a point input x, output 1 over 1 minus x. So how do you get the slope? The slope is difference in y coordinates, 1 over 1 minus x minus of minus 1, divided by difference in x coordinate. So it's 1 over 1 minus x plus 1 over x minus 2. That is our slope equation for this problem. So we are going to input this equation MPQ 1 over 1 minus x plus 1 over x minus 2 into y1. So because it's a fractional form, you may want to do alpha and alpha and y equal to and bring that fraction form. And also on the numerator, once again, I see a fraction. So I'm going to use alpha y equal to, and then choose the one menu which says numerator over denominator. So on the numerator, I'm going to plug in 1 over 1 minus x, and then come out of it, and then plug in plus 1. That finishes the numerator. Denominator is x minus 2. X minus 2. Then you make sure your table set is, as we mentioned earlier, we have to make sure that independent variable is in the ask mode. Hit enter. Now you're going to the table and then you're going to input the values that are given. So I've created a table right below with the point 1.5 for the first value, that is equal to 2. Then 1.9, that is going to give us 1.1111. So these are the values I'm going to be plugging in, filling the table. So as the problem is asking you to make sure that it is 6 decimal places, even though the calculator shows only 4 decimal places, if you go use your right arrow, below you see all the decimal places, right? So we will write up to 6 decimal places, 1.11111, and then the next value that you have to input is 1.99. So input that 1.99, hit enter, that gives me this value, but you can go right there and see how many decimal points we need. We need 6 decimal points. So it's 1.010101. So I have set of values to the left of 2, and I have the set of values to the right of 2, as shown in the problem. So for all of this, I'm going to use the table feature like this, and I'm going to complete the table. So let me give you a second. You do the same thing in your calculator. Good, guys. You all did this table. So from the table, I noticed that for all the values to the left of 2, my values of the slope are steadily decreasing from 2, and it approaches the value 2. So for all the values of x to the right of 2, for all the points of q to the right of p, the slope, if you look at these values over here, they are increasing slowly and this approaches the value 1. And here also they approach the value 1. So the slope, all the slopes, the limit of the slopes of the secant lines is going to be, in this case, both from the left and from the right, all of them approaching the value 1. So that is called the limit. Limit of the slope of the secant lines is 1. So the limit of the slopes of the secant lines PQ is 1. In other words, the slope of the tangent line at P, in this case, it is 2, -1, is 1. So the slope is 1. So the equation of the tangent at 2, -1 is, we have the point and we have the slope. So we can write down the equation of the tangent line. Y minus y1 equal to m times x minus x1. That is y minus of -1. M is 1 in this case. X minus x1 is 2. That is y plus 1 equal to x minus 2. So y equal to x minus 3. That is the equation of the tangent line. Hope this video helps, and this is part 1 of section 2.1. And then I will be doing part 2. Watch my next video, which is part 2 on section 2.1, where we will talk about velocity problem. Hope this video helps.